Hello, this is Dr. Phil Rosenkrantz again with EGR403 Online. This is our 12th presentation. We're covering Chapter 9, which is Benefit-Cost Ratio Analysis and Other Analysis Methods. If you go to slide number 2 on our big picture, we're getting near the end of our discussion of various analysis methods, and this is kind of the catch-all chapter. The most important part of the chapter is about benefit-cost ratio analysis, but the other methods are useful to know about. And so let's go ahead and jump into it with slide number 3. The methods that we're going to talk about are future worth analysis, benefit cost ratio analysis, payback period, and then sensitivity and break-even analysis, with most of the emphasis being on benefit cost ratio analysis and probably sensitivity analysis. Let's go to slide number 4 and look at future worth analysis. Future worth approach is very similar to the present worth approach. If you recall, with present worth, we resolved everything to a present value and did our comparisons. With future worth analysis, we do the same thing, except instead of getting the present worth, we find the future worth at some point in time that we establish. And let's look at example 9.1 here for our first example with future worth analysis. And let's say we wanted to look at the future worth at some of our spending. And the example we're using here is for smoking and spirits. And not that we're here to preach at you, but maybe there might be some lessons here. And how convenient that this is in the book. But anyway, it shows here that what if you spent on a semi-annual basis $15 a week on cigarettes, and so that'd be 26 weeks, and so on a semi-annual basis that would be $390. What is the future worth of that expenditure? And in this example we're going to look at age 65, and we're assuming that the person is now 20 years old, so this is 45 years into the future. What would this be worth if that money, instead of being spent on cigarettes or cigars, was invested? What would it be worth in 45 years? Well, for cigarettes, if you invested that money at 5%, you see that the future worth is $128,000 plus. And if you used 12% of your as an interest rate, let's say that you were a good market investor, that would be $1,225,000. Well, that's interesting. Let's compare that to what if you smoked one cigar a week at $1 for each week. That would work out to, without getting into the details, $81,000 at the end of 45 years. And for spirits, it's got some more calculations below, and with the assumptions that were made, it showed, for example, spending $6 a week on beer or $15 every month on liquor. I imagine they're talking there about something like hard liquor, or $8 every 2 weeks, say on a bottle of wine. Then you would get those cash flows that are shown out there. And if you added all those up, you see that that's a future value at 5% of almost $250,000, or at 12% of $2.5 million. Wow, those are pretty big numbers, aren't they? Well, maybe there's some food for thought, but for comparison's sake, what you're comparing are the values at the end of 45 years. Let's move to slide number 5 for another example. This is an example where we're comparing two different ways that a company could choose to expand their capacity. They're trying to minimize the present worth of cost because they have a fixed output. One alternative is to construct a new plant. Another alternative is to remodel an available factory. And you can see that both of these projects have a similar total output. If you add up the expenses in the first 3 years for the construction option, you get, if say these are in tens of thousands of dollars, you have $1,685,000. And for the remodel, it's $1,600,000. Now you would think that the constructing the new plant being higher would be less desirable than the remodel option. But if you look at the future worth of those two options at 8%, and 8% is our assumed minimum attractive rate of return here, then you'll see that the the future worth at the MARR is less with the construction option. Now, why is that? Well, the reason is because the expenses for the remodel option are more upfront. You have to spend that money earlier. Whereas with the construction option, the third year with $1,200,000 has kind of a delayed spending, and so that affects the future worth because of the time value of money. So anyway, this is meant to illustrate that the future worth analysis will also take into account the timing of the expenditures. Let's move to slide number 6 and switch to benefit cost ratio analysis. This is based on the formula that says the present worth of benefits minus the present worth of costs needs to be greater than or equal to 0. If you rearrange the formula, and if you divide the present worth of benefits by the present worth of costs, then we need to have a ratio that's greater than or equal to 1 in order to keep this equation holding. Now, if we've got fixed input situation, then what we're looking for is the alternative that maximizes the ratio of benefit to cost. And these are figured at the MARR. And here's an example that takes cash flows and two different cash flows. This is example 9.3. And if you find the present worth of benefits and the present worth of costs, and then form a ratio of those, you'll see that those numbers given for each one, and the higher of the two would be the best one if we have a fixed input situation. So when we have fixed input or fixed output, then we're maximizing the benefit cost ratio. Okay, now let's go to slide number 7. And again, we're talking about the ratio of the present worth of benefits to the present worth of costs. But if neither input nor output is fixed, in other words, if we don't have a fixed input or a fixed output situation, then we have to use incremental benefit cost ratio analysis. Here's a very important note, and that is that salvage value now is considered to be a negative cost and not a benefit. Up until now, we could call salvage value a negative cost or a benefit, and it didn't affect our analysis calculations. But now we're at a point where we have to treat the salvage value as an offset to cost and not as a benefit. In other words, it's going to end up in the denominator, not in the numerator. If we treated it as a benefit, it would be in the numerator of the benefit cost ratio. But we're going to put it in the denominator. We're going to subtract the present worth of the salvage value from the present worth of cost. And that's how we treat it as a negative cost. Now this method, the benefit cost ratio analysis method, is widely used in government because it's very amenable to be used with databases and spreadsheets and with lots of projects. Okay, let's go to slide number 8. We're going to look at the same example we looked at before, And you can see the data is arranged from lowest cost to highest cost. The benefit cost ratio is calculated for each of the alternatives. Each one is greater than or equal to 1, so we would retain all of these alternatives for analysis at this point. For incremental analysis, we're going to pair them off, again, lowest cost to highest cost, and we're going to examine the ratio, the benefit cost ratio for each increment. And those are all shown there. For example, for the B minus D alternative, the present worth of cost is increment is 2,000 minus 1,000, and the present worth of benefit increment is 3360 minus, it's 4,700 minus 1346, resulting in 3360, and then the ratio is 3.36 of benefits to cost. Let's go to slide number 9 and look at our first increment and examine it. We have a benefit cost ratio for the first increment, the highlighted area of 3.36, which is greater than 1, so we would retain B, and we would go to the next increment and continue. Let's go to slide number 10, and we get to our very last increment. It's E minus A. We've been retaining A. The benefit cost ratio is less than 1, so we would reject the higher cost alternative, and again, we've chosen A. With this method, we should get the same answer as we got with incremental analysis, which is the same as we should get with rate of return analysis, which is the same as we should get with annual worth analysis. So these four methods, if all assumptions and guidelines are used, should give you the same answer for the same set of data. If they didn't, then we would have some other issues to deal with. Let's go to slide number 11 and talk about our third method here, which is payback period. Here's some important points about it. It's an approximate method. It ignores what happens after the payback period. It only looks at the cash flows that are in effect up to the payback period. And so it won't necessarily produce an answer that's consistent with all of our other methods. Here's how it works. What we're doing is we're trying to determine how long it's going to take us to recuperate our investment. How many years will it take us to get our money back? If we look at this example, 9-6, on slide number 12, we see that we're actually using the same example we used in one of our earlier presentations, where we had sale co versus lease co. And here we have the cash flows shown. And if we look at payback period, we ask ourselves, how long will it take us before we recuperate our initial investment? And we see that for alternative A, it takes us 2.5 years to recuperate our initial investment of $1,000. Alternative B, it takes only 2.3 years to recuperate our initial investment. So based on the idea of payback period, which is the alternative that gets us our return back the fastest, gets us our investment back the fastest, is the best, then B would be preferred, 2.3 years. But if you'll recall, using present worth and annual worth analysis, we found that, or incremental rate of return analysis, we found that alternative A was preferred. It wasn't justified to spend the increment. So payback period doesn't necessarily give us the same answer as the other methods. Let's go to slide number 13 for another example, and this is a very dramatic example. We see here two cash flows, and it turns out that the first series of cash flows, we recuperate our investment at the end of 4 years. The second cash flows, alternative B, it takes us 5 years to get our money back, but you'll notice that this particular project keeps generating revenue clear until the 8th year, whereas the first one, it stops after 4. The rate of return on the first alternative is 0% actually, because we don't get anything back after we recuperate our investment. Alternative B has a 19% rate of return. So, based on payback period criteria, we would select A. Based on rate of return analysis of any kind, we would pick B. And I think you would agree with me, you'd rather have B than A. So why is payback period used? Why would you even care about it? Well, it's used in many cases because it's simple and easy to understand, and anybody in management can understand this method without having to understand interest rates, how to figure out rate of return, how to do present worth analysis. It doesn't require any mathematics other than what you would need to figure out when you've got your money back. So it's simple to use, and in some companies they use it because everybody can understand it. If you go into a company like that and you suggest using equivalence methods, you may run into some resistance, but it's worth trying to explain to people the importance of taking into consideration the time value of money. Where payback period is useful is in conjunction with the other methods. For example, you may be in a particular cash flow crunch in your company, and so you might have to put an additional payback period criteria on your projects and say that you'll only use MARR equal to 10% projects, and all projects have to have a payback of, say, 3 or 4 or 5 years. And what that does is it takes into account then the cash flow needs of the company as well as the return needs. Okay, let's move on to slide number 14, sensitivity and break-even analysis. And the reason that we need to bring this up, we've already done break-even analysis. I'm not going to actually go through it here, but it's mentioned in your book at this point. We covered it earlier. But sensitivity analysis is very important, and you're going to be expected to use it in the course in some projects. When we are doing any of these analyses, we're trying to estimate cash flows. So we're using estimates in the future. Sometimes these are very educated guesses, but many times they're just best guesses. These projections ultimately affect our decision, and sometimes it's helpful to play a what-if game and say, what if my estimates aren't right and I make some variations in them, plus or minus? What would that do to my decision that I'm making with my analysis method? And that's very helpful because sometimes you're very close in your alternatives, and just one or two assumptions that you make, if you're a little off, could affect your choice of alternatives. So let's look at an example. I'm going to use problem 621, which you may have done in your homework. If not, I'm showing it to you here, and it's based on a comparison of a cab company that's choosing between diesel engine cabs or gasoline engine cabs. And with the data given, the EUAC is calculated for both the diesel engine alternative and the gas engine alternative, and if you're trying to minimize the present worth of cost, the diesel alternative looks best because it has an EUAC of 4,780 compared to an EUAC of 5,157. But what if we wanted to look at the impact of our assumption on what the price of gasoline would be, or the price of diesel would be? Let's go to slide number 16, and we used in this example a 48 cents per liter cost for diesel fuel in the original analysis. But what if that cost were to be higher? At what point does the diesel engine alternative equal the gasoline cost alternative? And by just plugging in different values of diesel cost, we can see what the EUAC for the diesel option becomes. And it turns out that the price of diesel would have to go up to 75 cents a liter before the gasoline alternative becomes preferred. Now this is good information because somebody might be able to make a pretty good judgment about the likelihood of diesel fuel costs going up from 48 to 75 cents with gasoline holding the same. But it gives you a chance to evaluate that parameter in your analysis. Well, let's examine another parameter. Let's go to slide number 17. Let's see what the impact would be if we were to be incorrect or have some variation in the resale value of the gasoline-powered car. We used 3,000 in our analysis, but if we look at some other values, what does that do to our EUAC? And you can see the impact there, and it turns out that if the resale value was 4,200 instead of 3,000, that the gasoline alternative is actually equal to the diesel alternative. And so you can ask yourself if that $1,200 difference in what you estimated originally and what would make them equal, what's the likelihood of that happening? And then you can get an idea of how hard or soft your decision is. So this is what sensitivity analysis is. It's varying your parameters, varying your estimates, and seeing what impact that has on your decision. Well, that wraps up chapter number 9 and the analysis methods. We'll be moving on to some other techniques and enhancements in chapters 10, 11, and 12. Thank you. Bye.